Welcome to the world of robots. Industrial robots are multifunctional machines equipped with 3 or more axes of motion, comprising both rotational and linear joints. Common types of industrial robots encompass articulated robots, Cartesian robots, SCARA robots, and parallel robots. Articulated robots, especially 6-axis configurations, are prevalent in industrial applications owing to their extensive degrees of freedom. These robots can execute movements in a 3-dimensional Cartesian coordinate system along the X, Y, and Z axes, as well as rotations around these axes, commonly referred to as roll, pitch, and yaw. Each rotational axis is typically actuated by a dedicated electric motor. Controller and flex pendant. Emergency stop button. The emergency stop button is used to immediately halt the robot's operation in case of an emergency. Operating modes. Manual, teach, mode. This mode is used for manual control of the robot for setup and testing purposes. For initial setup, start in this mode. Auto mode. This mode allows the robot to operate automatically according to a pre-programmed sequence. Robot status indicators. The motor ON indicator, a white light located below the emergency stop button, indicates the status of the robot's motors. In manual mode, the light will blink until the operator presses the enabling device button, at which point it will turn solid white to indicate readiness. In auto mode, pressing the enabling device button once will initiate the robot's programmed sequence. Robot control menu. A robot, after being set up by a trainer, utilizes 4 primary menus for operation. Jogging. This mode allows for manual, incremental control of the robot's movement. Production window. This is where pre-programmed automation routines are executed. Program editor. This is used to create and modify programs that control the robot's actions. Program data. This stores various robot parameters and settings. Operating the robot with a flex pendant. To control the robot's movement, insert your left hand into the flex pendant and press the enabling device, dead man's grip. This button has 3 positions and should be pressed with 4 fingers. Center position activates the robot's motors, allowing it to move. Release immediately stops all robot movement. The ABB IRB 120 robot has the following specifications. It can handle a maximum payload of 3 kilograms and has a maximum reach of 580 millimeters. The robot features 6 axes of movement, enabling versatile and flexible operations. It weighs 25 kilograms, making it lightweight and easy to install. The robot achieves a repeatability of plus or minus 0.01 millimeters, ensuring high precision in tasks. It operates with a power supply range of 200-600 V at 50 to 60 Hz. The environment rating is IP30, suitable for general indoor applications. It supports multiple mounting options, including floor, wall, and ceiling installations. For movement, the robot's axes have specific ranges. Axis 1 rotates up to plus or minus 165 degrees. Axis 2 moves between minus 110 degrees and plus 110 degrees. Axis 3 covers a range of minus 110 degrees to plus 70 degrees. Axis 4 can rotate plus or minus 160 degrees. Axis 5 has a range of plus or minus 120 degrees. Axis 6 rotates up to plus or minus 400 degrees. This combination of features ensures the robot is compact, efficient, and highly adaptable to various industrial applications.
Delta Robot, designed for use in automated production lines. It features a unique structure that allows it to move with high speed and precision for picking, placing, or handling objects on a conveyor belt. Delta Robot. Main structure: the robot is mounted on a frame, featuring a tripod mechanism with 3 arms driven by individual motors to control the position of the end effector. Movement: the robot's arms can move along the X, Y, and Z axes, and some models can rotate objects to adjust their orientation. Key features: Delta robots are fast and are ideal for handling lightweight objects or small items at a rapid pace. Conveyor belt. Primary function, used to transport objects or items through the area where the robot can pick them up. Integration, often equipped with sensors or vision systems to detect the position of objects on the conveyor. Control cabinet. Located on the right side of the image, it includes status lights, e.g., green, red, and a touch screen, HMI, for setting parameters or controlling processes. The control cabinet connects to the robot and conveyor belt via industrial communication protocols such as Modbus or EtherCAT. Control software processes data such as image recognition, position calculation, and sends commands to the robot's motors. Display screen. A screen is visible on the front, likely used for monitoring the operation or adjusting settings. Machine vision system. A camera or sensor positioned above analyzes objects, such as their shape, color, or size. This technology processes and sends position coordinates to the Delta robot for precise picking. Benefits of this system. Enhanced efficiency, operates continuously without breaks, reducing delays compared to manual work. Error reduction, the use of cameras and image processing software minimizes errors in sorting or handling. Labor cost savings, reduces the need for manual labor in repetitive, precision-demanding tasks. Flexible configuration, can be reprogrammed or fitted with different end effectors to handle a variety of products. Application examples. In the food industry, sorting food items, e.g., bread or cookies, and arranging them in packaging. In the pharmaceutical industry, picking and handling pills or pharmaceutical packages. In the electronics industry, sorting and arranging electronic components on circuit boards.